All right, so let's get started. My name is Felix, and I'm going to be presenting what I call Reconstructing Scala. So first, what do I do? Well, I'm a compiler engineer with LAMP. That means that Martin is my boss, and he tells me what to do, and I try to do my best to satisfy him. And yeah, right, one more thing. Slides are available on this website if you can all, if you actually have internet access this time around, and you want to backtrack or whatever, the slides are available here. And also, this is a conversation. This is not a talk. So please, if you have questions at any time, you want to yell profanity, that's fine too. I won't personally take offense. But please, if there's anything, just interrupt me. So the first thing I wanted to do was actually take a trip down memory lane to realize why we are doing this, why we are reconstructing Scala. So this quote here is from 2004 by Martin during the original inception of Scala. And I read, "We'd like to announce availability of the first implementation of the Scala programming language. Scala smoothly integrates object-oriented and functional programming. It is designed to express common programming patterns in a concise, elegant, and type-safe way. Scala introduces several innovative language constructs, for instance, abstract types and mixing composition that unify ideas from object and module systems. Pattern matching over class hierarchies unifies functional and object-oriented data access. It greatly simplifies the processing of XML trees. A flexible syntax and type system enables the construction of advanced libraries in a new domain-specific language. At the same time, Scala is compatible with Java. Java libraries and frameworks can be used without glue code or additional declarations. The current implementation of Scala runs on Java VM. It requires JDK 1.4 and can run on Windows, Mac OS, Linux, Solaris, and most other operating systems. A .NET version of Scala is currently under development." So, how many people can spot things that are currently not true with Scala in this? So there are a couple of things, right? So, first of all, there's no longer a .NET platform as far as I know. And XML trees, we all realized that was a bad idea from Martin's speech the other day. So, what happened with the language and what was new in the different versions? That's something that I didn't know up until I decided to, put this talk together, and I thought it would be interesting to share it with you guys. So, in the first version of Scala, this is what I found to be the significant things that Scala added to the language. So we had algebraic data types, functions as values, generics, and biname parameters. And if you don't know, biname parameters is this last thing here, where if you pass something by name, then it won't get evaluated unless it's accessed. And it also had this thing called parameterless methods. So even though you had a method declaration, you could access it without having to apply it with parents. And there was also this other function, or this other functionality that said that we always eta expand partially applied functions. So for instance, if you wanted to define a square function using the map function here, then you could simply do map x times x, right? But this unfortunately led to some surprising behavior. And does anybody know why? Dennis is really eager. It will print function instead of colon x. So these two features together had some surprising behavior. So when it came to Scala 2, this was the time to fix those things, right? So I call this a time where cake didn't make them fat, because this was the time where Martin introduced the cake pattern and built it into the Scala compiler. Great times. So the new things in Scala 2.0 was that we would auto-add parents if the reference was to a null-array function. And we would only eta expand in these two cases. So this essentially fixed the issue that Scala 1.0 had by just applying this simple heuristic. Other things that were added were such things as the implicit keyword, match, requires, which was at the time a way to syntactically express self-types. And also private qualifiers were added. And last, and most importantly, I think, is the implicit parameters. And this, to me, is what makes Scala Scala. And throughout the 2.x series of Scala, we continuously added lots of things. So in Scala 2.1, we got multi-line strings, we got class literals, we got protected qualifiers, which sort of makes sense since we here had private qualifiers, so that's natural, right? In 2.4, we introduced procedure syntax. And this is something that we are, again, removing in Dotty. We also have tuples and extractors. And the current syntax for self-types was introduced. And the last thing on this list that really annoys Martin, I know, is that case classes at this point cannot be abstract. Does anybody know what abstract case classes do? All right. So abstract case classes allow you to yourself define the apply method. So you can have smart constructors. And this is something that we use vigorously throughout the Dotty compiler. But at this point, it would not be possible to add this. In Scala 2.4 and 2.5, there were basically only these two features, so I decided to bunch them together. And at this point, we added private this and early initialization. So, and here, let's see. So 2.6. This, I originally called this the mellow period of Scala, but then I consulted Martin, and that was plainly wrong, because this is the Sturm und Drang period of Scala, where we add existential types, lazy values, structural types, and higher-kinded types to a certain degree. In 2.7, Martin got his revenge, and now case classes may again be abstract. And we had other functionality here as well. Case classes got extractor methods by default, something that was not there before. Case classes were allowed to have companions, something that was not allowed previously. And also, mixing Scala and Java in the same project was now allowed. So you can see that slowly, this is turning into the Scala that you all know, right? And that I know. And Scala 2.8 sort of marks this end of puberty. Like we have a maturing language with a redesigned collections API. We get specialization using the @specialized annotation. We get named and default arguments and package objects. So at this point, we're sort of fully formed. And then 2.9 is sort of a beefing up. We get the parallel collections, the delayed init, and the app trait. And 2.10, for me this sort of marks the end of adolescence. At this point we get value classes, implicit classes, string interpolation, dependent method types, Scala reflection, and macros. So at this point we are fully formed. This is the language that you all know. So looking back at this, you can say that this is Scala as it is today. And the common theme up until this point is we have a lot of growth, we get a lot of experimentation, and a lot of maturing features. But then again, nearly nothing is removed from the language. Instead, we iterate on these features and we replace them as they come. And the future 2.x versions, that is 2.11 and 2.12, their main focus is on internals and stability. So why was this growth so rapid in the beginning of Scala? What was it that prompted this? Well, first of all, Scala was a new language. And for adoption's sake, when people asked for a certain feature where they said, hey, if Scala only had this one feature, then I could run my company on Scala. So of course, that's a really big incentive for the lab at this point to implement that feature. And that is exactly the second point. It was also developed at a university, at EPFL. And the people who were working on this were the PhD students and, of course, Martin. And these students all wanted to see their work applied in real life, and as such, were really, keen on getting things in. So, at this point, now we arrive at Reconstructing Scala. So what I mean by this is that at this point in time, we decided that we need a new compiler. And what we need to do for that is actually reconstruct the language from scratch. And we want to take the lessons that we learned in the 2.10 series, 2.11 and 2.12, that were more focused on stability. But we also really want this spirit of the earlier releases where we are allowed to evolve the language, we're allowed to try new things, and we're allowed to sort of iterate on what Scala is. And this is all Dotty. So, Dotty is simplification, developer usability, and correctness. And that comes from this dot that we were talking about earlier. So dot, as Martin mentioned, stands for dependent object types. And this is a lambda calculus that has a proven foundation. That means that we can be confident that the language itself is correct. And then we take this small subset of the language and we expand it so we can prove that larger portions of the Scala language are indeed correct. And of course, and more importantly for you all, this eventually will be Scala 3. So, I wanted to take a quick look at people who are working at this project. So, as you can see, there's one guy who's really on fire up here. And you can see, I've been working a hell of a lot to be able to put up these numbers. But even if you take all the contributors combined in the Dotty project, and you compare their commits against Martin's, we're still short 150 commits. So Martin really does outshine us in commits, at least. And you can see that number 8 here, Enno, is actually an external contributor who has been doing a lot in the Dotty project. And I will tell you more about how he's done this and what's been the focus. So what am I passionate about in this project? So I'm really passionate about ergonomics, that is usability of the compiler itself. So one of the things I wanted to do was to provide Dotty with incredible error messages. And not just error messages that look pretty in the console, but error messages that actually carry semantic meaning. And what it means is that we're not just giving a string to an IDE. Instead, we're giving them a semantic object that they can reason about, which means that the IDE itself is allowed to present the error in any way they so choose. And secondly, I've been working on this thing called the Dotty.compiler. And yes, if you didn't know, I'm the guy who's responsible for the 2.12 docs. So if you want to scream at me later, please bring me a beer beforehand. So yeah, let's talk about getting started with Dotty. Because this project is now, as Martin mentioned yesterday, we actually released a version of this, and it's ready for, the more enthusiastic part of the crowd to play and experiment with. So how do you get your hands on this? Well, the first alternative is using Scasty. So Scasty is this JS Fiddle-like website that Guillaume from the Scala Center produced. And I was originally thinking of going to the site and showing you guys how this looks, but from past experience, we all know there's no internet connection here. So I'll just tell you that it's there, and it's really nice. The second way how to do this is to install it via Brew. So obviously, that's only going to work on Mac OS. And the third alternative is using the SBT new command to use this template. So let's start with Brew. So I actually cached this. So I already did Brew install. So hopefully this should just be picking up the local copy and not, forcing me to stand here and stall while Homebrew does its thing. All right, cool. So at this point, we can run .r. So .r gives us a REPL. So this is a standard Scala REPL. I hope you can all see this. That brings some cool things like color highlighting. It also does proper line wrapping like this, so you don't get the really weird pipes you can just paste into it. So you can, here you can do whatever, you can do WildX. Oh, we can do cool things, right? We're Dotty. All right, stuff like this. All right, great. So the other way is to use SPT. So SPT new. I should not do this in this project. Let's go to temp. All right. So this, of course, will take a while because it's SPT. So meanwhile, we're going to fire up SPT inside the Dotty project. All right, we can name it Scala Days. Something like this, Scala Days. All right, so at this point, you get a standard SPT structure that has a bunch of different things. But the most important part is that the build.spt file and the plugins SPT file, they make sure that Dotty is your compiler. So at this point, it's just a matter of firing up SPT inside this directory, and then waiting for the startup time and the presenter to stall while SPT does all the resolution and things like this. All right, and then at this point, you can do compile. And then as you can see, it fetches Dotty library, blah, 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 and everything seems fine and dandy. All right, and you can even do things like test, or you can do run, or you can do console. And if you do console, you can see that we get the same REPL as we had earlier. Pretty cool. All right. So there is more to this than I previously stated. And how many people are familiar with the language server protocol? All right, a bunch of people. So what we do is that in SPT, in any Dotty project, you can call this command called launch IDE. And then you get this file. You get the, let's see, can I make this bigger? Yes. And then you get a IDE from Visual Studio Code, which is what we're supporting at this moment. So at this point, you can do things like go to definition, and it will jump to the proper definition. And I actually opened this in the Dotty project itself because I wanted to show you that it actually works for a pretty big project. So if we want to go to definition for this guy, it does work. Wow. Yeah. But, so, unfortunately, I am not a person that uses IDEs. I use VI, and when I told Martin this, he told me, so you're brain dead. So, hopefully throughout this year, I've proven that I'm not entirely brain dead, at least. All right, and so, so now we've seen Brew, and we've seen IDE. So let's take a look at DottyDoc. So DottyDoc is the next thing. All right, so cool. So here I just created a small project. Let's make that bigger for you guys. So here, like a standard project would be you have some sources and then you have some documentation. So in the docs, we can see I have this theme song that people are probably familiar with. So this is a standard markdown file, and it features my favorite TV show. So this project, what it does is that it models the Friends TV series. So it's just a simple project to illustrate how DottyDoc works. So if we want to use DottyDoc with this, what we do is we call the .d command, which was installed by Brew. And then you can do -site root, and you point it to where all your markdown files were. And then we just say, well, the name of the project is Friends, the version is 0.1, and these are the sources. And don't worry, SPT integration is coming, so you can just type doc. And then it runs the documentation on both your sources and these markdown files. And at this point, you get a nice little summary of how much of your documentation or how much of your sources was actually annotated with doc strings. So you sort of get this like nice report card. And if you're like me, you want to gamify and you want to get to 100%, then you know like where to look. So it does this both for your public API, your Surface API, and for your private API. So those are two different metrics. All right, so actually let's have a look at this. So I know for a fact that it's going to be generated into this file, which I should not do like that. I should do open, right? All right, so at this point you can see that the markdown file was translated to some form of HTML, and then it looks kind of ugly. So we should actually, here, we should give it some layout, and we should give it one of the standard ones that Dotty comes with, so a doc page, for instance. So then we regenerate that, and now we get some nice documentation. So as you can see, like in a standard project, you would have like a docs directory, you would have a bunch of reference that would explain how your system works, what to look for, etc. And as you can see here, you also have the API in the column to the left. So at this point, we can just go to, well, let's say characters, for instance. And here we see the definition of characters. All right, so this is all cool, but as you can see, here I have the theme song, but I also have this trait, which also had the theme song in the doc string. All right, so that's duplication. That should go, right? So how do we do this? Well, in docs and in index, here we should just delete this, right? And then we should do doc string, if I can spell. And we should do friends theme song. All right. So at this point, of course, this one's going to be the same, right? And now this one's the same. So now we actually have documentation which is in sync with our doc strings. So I mean, the doc strings we keep for our contributors and for ourselves so we can understand what we're doing. But the reference, it should follow it one-to-one. So this is a typical problem that I'm sure all of you have with documentation, and that's probably why you're not writing it. All right, so let's see. Are there other things I want to show? No, I think we're good for a while. And of course, yeah, I should showcase this as well. So this is the Dotty website. Maybe some of you have been to it. It has a bunch of information about Dotty. And if you look here on the upper right-hand side, there's a docs link that I won't click because I'm not, I don't trust the internet here. But it generates this really nice documentation. So actually the entire site used to be this statically generated thing that Jekyll did. And now we just provided the same thing, but with DottyDoc. So DottyDoc is like a full-blown site generator where you can cross-reference things between the source code and the actual documentation. All right, so let's get back to the presentation. Yeah, the second thing is awesome error messages. And so I should probably showcase some of that, right? So, oh, that does not work in a REPL. All right, so let's do def foo is a list of int. And then we should do like this, right? All right, that's all good. So if we then define bar to be a list of string, and then we refer to foo. At this point, Dotty gives you a really nice error message. So Dotty actually tells you in the type where you went wrong. So we have this built-in type diff tool that shows you exactly at which point something is wrong with your type. So you can actually get something better out of the error messages, despite instead of this like huge wall of text where you're not really sure where one error message begins and the other one starts. Here you get something that's really nicely separated. All right. So there are more cool error messages. For instance, we can do something like, let's do class foo def bar returns a singleton 1, and then we do new foo, and then we do res1 dot bar. So now we actually get some information about, oh, you actually mistyped this. It should be bar instead. So, I mean, and as I said, these error messages are semantics. So that means that your IDE can pick this up and make the suggestion for you instead. And we provide this free of charge. And there are loads of different cool error messages like this. And I really want to give some props to all these people who have been helping out on the awesome error messages. So these guys have been porting over, I think, 150 error messages now in the compiler. So they all deserve a round of applause, in my opinion. And I know for a fact some of them are here today. All right, so we're done with that. So there are a few things else that I could speak about. We have lots of differences in the Dotty codebase, and one of the things that we've learned over the history of Scala is that we should evolve things at a slow pace, where users have time to adapt. But the time to do that is now, and so we're introducing all these cool new features. And one of them is, of course, enums that Martin talked about, but there are loads of different things. The IDE, of course, Visual Studio Code, which, since it's based on a language server protocol, it allows me to use my favorite editor, VI, as I said before. And yeah, and there's also lots of other cool things like this typed abstract syntax tree, which is also really great. I should actually talk a bit about type inference, because one of these usability things is actually just that. Type inferencing is really important to most people who use the compiler. And one of the most annoying things when you're a beginner in Scala is this right here. Does anybody know if this compiles? Nobody knows if it compiles, or you're just not sure. You know if it compiles. Right. It does not compile, right? In Scala C, it does not compile. But what if I told you that in another compiler, it does compile? So in Dotty, it does compile. And this is because we have a different way to do inferencing in Dotty. So let's just quickly see what happens if we do like list.range 10, follow the right, list empty, and then we reverse it. All right, so this works. Or does it? List any, right? That's bad, right? We're losing precision here. So that sucks. Well, what if we do this? Then that shouldn't work, right? But it does. Because Dotty will take this into account when doing type inferencing. We'll see if, hey, can we actually fit these types together? And if it does, then you're left with this much better inferencing in this case. All right. So one of the other things I wanted to mention again is implicit functions. And as Martin talked about yesterday, they have this great way to capture context. That, of course, is not the only reason why we're investigating implicit functions. We also plan on having some form of effect system into Dotty. And they would be modeled using implicits, and implicit functions sort of capture the essence of this, since you're allowed to abstract over them. And, of course, an implicit function is simply this. And now, I want to take a moment for our Lord and Savior, tagless final interpreters. And this is the new hipster thing in Scala, right? So how does this look? What is it first and foremost, what is it? So if you have this sealed ADT, that's just an expression. It's just a way to model an expression. So you have an add and you have a literal. So the way you build an expression in this case is something like this, right? So at this point, you say, well, let's add 8 to 2 and 2 and 2 and 2. All right, and then we provide some implicit evidence, some implicit eval to do this. So we have to have some type class like this. And then we have the apply method, which simply does the calculation, right? So this is one really composable way to do it. But what happens when we want multiplication? All right, so let's go back. So when we want multiplication, we have to add something to our sealed ADT. We have to add multiplication. And of course, we have to add multiplication here as well to the type class. But what if we have already built lots of interpreters using this model already? We'd be breaking all of those, right? You'd be getting match errors in these evaluations, right? So instead, if you do the tagless approach, you can model it as simply as a trait like this, and you use functions instead to denote the different parts of the ADT. So at this point here, you can see that I've basically just transformed this sealed ADT expression like this into a trait with 2 defs. And at this point, you can see that this guy here, he can evaluate ints. And if I then want to add multiplication, sorry, this is just so syntax will be lighter. If I then want to add multiplication, I can simply make another trait for multiplication. And then, in the end, in my expression here, I have simplified from adding 2 a bunch of times to just multiplying 2 by 3. So at this point here, we're just injecting another type class, which doesn't break any of the existing interpreters, which is a much better way to do things. So what happens if you continuously add these type classes? And of course, your signatures are going to get huge. So one way to abstract over this is using implicit functions. So using implicit functions here, you would simply create some type constructor, which takes a t, and then you have on the right-hand side an implicit function with the expression and multiplication, which returns a t. And then here, in the end, you just say, well, my expression is simply of the type ring. And then you get all of these for free. And of course, the rings themselves, of course, they compose. So you can add multiple of them together, you can chain them together and have something really nice. So, as I mentioned, one of the people here who's made the most contribution who is not part of the lab officially, he did lots of these awesome error messages. And I think that's one of the easiest ways to actually get into programming on this project. Because right now, Dotty is this really small-ish projects of 80K lines of code or something like this. I think 40K in the core. But we really made an effort to make it easy for contributors to get into programming in Dotty. So what we do is all issues that we think are bite-sized appropriate, we mark them with help wanted. We also indicate the level of experience on most issues. To sort of guide you if you have I have an hour off, I want to do something fun for open source. And for these awesome error messages, we actually have a complete guide that tells you exactly what to do if you want to help and contribute and test your solution and so on. So I really highly recommend taking that path into the compiler if you guys are interested in helping out. And of course, one of the most important things is that these are things that you guys will all be using. So it makes sense for you guys to invest in the tooling around the compiler, the REPL, the IDEs, the build tools, and the error messages. And last off, I sort of want to leave you guys off with some answers. Usually you guys get to ask questions. I'll just tell you answers. So one question I get repeatedly is, why this weird versioning number? Error. Yeah, and that's really just a product of us doing pre-release nightlies and having to bunch version numbers. So it doesn't have any semantic meaning. The next version that we will be releasing after this 0.1.2 series will be 0.2.0. All right. So. And also, people always have suggestions. Please be friendly and bring me a beer if you have a suggestion. I'll try to, smooth talk Martin into getting it into the language. And one of the things we get asked a lot is macros, because as Martin has previously stated, we don't have macros in Dotty currently. But the plan is to support Scala Meta macros and the Scala Meta API for these macros. And so that is the way forward. People have also asked me if we have implemented and solved SI 2712, and yes, we have. I think that was quite a while ago, actually, that we did. And when is the next release is also a good question. And that, as Martin said, is in 6 weeks. So every 6 weeks from now on, that is the way we will, that is the release schedule. All right, cool. So before I take any questions, I actually want to invite Martin Dudersky up on stage, since you guys didn't get to answer any questions on last night. So please make a round of applause for Martin. All right.
Thank you. From what I can tell, Dotty and Scala 3 are going to be a couple of years away. So for some of this stuff, like getting better error messages in the REPL and in our code in the compiler, is there a way that we can port that to Scala 2x?
Sure. I mean, of course, there's always a way if there's a will, right? But, I mean, so how many are we now? We're 10 people working on Dotty, I think, something like this.
What you showed up there was about 10, yeah?
Yeah,
so part-time.
Exactly.
Yeah.
So we're sort of like really focused on this project. We'd like, if anybody would like help on implementing this in the Scala 2 compiler, of course, we'd be there to support. But we're super focused on Dotty.
I mean, Seth is sitting right next to you, so maybe you have a comment. Okay, I think that the Scala C team is looking at it and sort of making a list of things that they might consider to port, time permitting, but they're also, I mean, heavily charged, of course, with these things. So I guess any help of the community on the Dotty side and on the Scala C side would definitely speed things up there. Yeah.
Hi, the thing with Scala currently is that interoperability between Scala and Java sometimes doesn't work super awesome, especially when it comes to lambdas. Are you going to fix it in Dotty? Do you plan to work on it?
What specific problem did you have in mind for interoperability?
Especially if you have to use Java lambdas inside of your Scala code. Of course, it's tricky. You can work around it with implicits, but it makes the code a little bit ugly.
To the degree of where this is possible, I guess both Scala 2 series and Scala 3 series will see what we can do, yeah. There might be some, I think there's some things that are right now not working so well, and it's not clear whether it's possible to make them work, but to the degree where this is possible, of course we would do it.
Hello. Can you comment anything about Scala native project? Anything related to maybe it will be official part of the Scala, not just a done separate project. I mean an official project. Scala native project.
Scala native.
Yeah, and also if you're aware, there is Oracle's Polyglot project, the same aims and like a Scala native. Any comments for it?
So about native, I mean, you have to give it time. I think it's coming along nicely. It's actually quite amazing what can be achieved with so few people moving that forward. But you have to give it time, and we have to see essentially how well it matures. I think there's a danger if we put it in too early, and essentially then, because the sooner it gets in, the sooner it gets frozen, and that means there's essentially no way to improve things as rapidly as before. So I think we have to find the right moment for that, but definitely, I mean, if things are progressing like they do now, then there will be a time where I'm quite confident that this will be part of the standard.
Hello. Maybe it will sound like a feature request, but anyway. We have a pattern matching, which is quite cool feature of the language, but it doesn't allow us to match with names. Maybe there's a jury issue from 2011, and I know people, they don't use pattern matching with just conventional pattern matching. They match type, because if you add a new field to the case class, you need to fix all the usages, and you need to add wildcard everywhere, right? So it's kind of boilerplate. And this feature doesn't have any focus. Is it considered or something? It does look like a very complicated change. For me.
Well,
I'm not a
so you say.
Thank you.
We take it under consideration. Yeah, yeah. Thanks.
All right, cool. I guess that's it. So thank you guys very much for listening.
Thank you.